So sorry about that. Okay, so now we have just these two general formulas that we're going to be looking at pretty much in depth today. We have this for geometric series, we're looking at 11.2, and then for the ratio test, we're looking at this formula, and that's kind of going to be what we're going to hit via a couple homework questions that I've picked out. As I said before, you have questions, feel free to put them in the chat. You want to go over specific homework questions, feel free to put them in the chat or just shout at me and we can cover them. So without further ado, the first question I would like to cover is going to be from section 11.2. We're going to be looking at number 2. And this question pretty much is asking, determine whether a geometric series is convergent or divergent. And we're given this geometric series. So they weren't very nice to us here. They didn't just give us a general form. So now we have to think about how are we going to find this ratio given what we have here. And this one's a little bit more difficult. We look at these first two numbers and it's hard to tell what we have kind of going on with the ratio. So I say, okay, let's take a look at the next two numbers and see what we have going on. So if we look at 25 over 6 and this 125 over 36, if we were to divide 125 by 25, we would have a 5, and 36 by 6 is a 6. So then let's just say, okay, we think our ratio then is 5/6. Let's take a look and see if that makes sense. So if we think about this first term, 6 times 5/6 is going to give us 5. And then if we have 5 times 5/6, we're going to get 25/6. So this then will be our ratio. Now, given what we know, we can say that 5/6 absolute value is less than or equal to 1. Check. So now this is going to be a convergent series, and we can find its sum. So to find its sum, we're going to use this S formula right above here, where A is our first term. In this case, 6 becomes A, and our radius then is 5/6. So then what we have is we have 6 over 1 minus 5/6. Okay? And then to solve this, what we can do is we can rewrite this 1 as 6 over 6. So we have 6/6 minus 5/6. So this is going to equal 6 over 1/6. And then we can just multiply by 6 to both the top and bottom. And now we're left with 36. So that is going to be the value that that geometric series converges to. All right. So up next, we're going to take a look at another series from 11.2. Another question, we're going to be looking at number 6, or number 5, I'm sorry, not number 6. Okay, and again, it's determine whether the geometric series is convergent or divergent. And we're given now just our general form, summation is n equals 1 to infinity of 9 over pi to the n. Okay. Yep, sorry. So taking a look at this right away, we're not really in a form where we can think about evaluating this, trying to find a ratio or anything else yet, because we don't have the whole thing to the nth power. So if we go ahead and take a look what we got going on, we can take this 9 and move it out front of the summation. And then we have 9 times summation from n equals 1 to infinity of 1 over pi to the n. This 1 over pi to the n can be rewritten as 9 summation n equals 1 to infinity 1 over pi all to the n. And the reason for this is 1 to any power is still 1. So we can always just make this whole thing to the n, because 1 to the n is 1 no matter what. So from here now we have a ratio, and our ratio then is going to be 1 over pi, which is going to be less than or equal to 1. So this series is going to be convergent. Okay, now we need to think about how we're going to solve what we're going to find. So now we need to get this general form. Our sum equals a over 1 minus r. Problem is we don't have an a yet. So when we think about these series, we need to think about this term a is the first term in our series. And our general form to solve this is going to be, I'm going to write it over here, summation n equals 1 to infinity of something. I'm just going to call it, I'll call it 1 over pi for now. 1 over pi, and this has to be to the n minus 1. So we think about what we got going on here. We need to take out a 1 minus pi to get n minus 1. So our first term then is just going to be 1 over pi. So the way we can think about that is 1 over pi to the n is equal to 1 over pi times 1 over pi to the n minus 1. And that's going to be our first, that's going to be our first term, that 1 over pi. So a then is going to be 1 over pi. So we have s equals 1 over pi divided by 1 minus 1 over pi. Okay, so then let's multiply the top and the bottom both by pi. And if we do that, I'm going to write it down here so you guys can see. We're going to be left with 1 divided by pi minus 1. And that right there is not quite our answer. So this is going to be what s equals. But going back up here, we factor out this 9 from in the beginning. So we need to multiply this by 9. So s then is really going to equal 9 times pi, or 9 divided by pi minus 1. Because we factor out that 9 in the beginning. Always remember to put that back in at the end. I almost forgot to do it. It happens a lot. Definitely try to remember to do that. So then this right here would be our final answer for question number 5. Are there any questions so far? If not, we will move on to a couple questions from homework 11.6. So what I will do is I will write our general formula back here again. So now we're going to move on to 11.6. Our general formula is going to be limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. Okay. So from there, I have just a couple questions from this as well I'd like to go over. This homework is a little bit shorter, so I figured 2 is a good kind of catch-all, and then I'll open it up to questions or whatever you guys have. So let's take a look at number 4 to start. So number 4. This question is asking, use the ratio test to determine whether the series is convergent or divergent. Okay, and they give us this series. Summation n equals 1 to infinity of n over 5 to the n. Okay, so now the first step of this question is to identify a sub n. A couple different ways we can do this. I like to kind of leave it just as is. So a sub n is going to equal n divided by 5 to the n. We could also rewrite it as n times 5 to the negative n. Whatever way you guys are more comfortable with, both of them are correct. Okay, so now we need to think about our limit and what we're going to do. So taking a look back here, this a sub n plus 1 pretty much is saying wherever we have an n, we're going to add 1. So let's do it. We got limit as n approaches infinity of a sub n plus 1. So we're going to have n plus 1 divided by 5 to the n plus 1. And that's all going to be divided by, I'm going to do it this way, and then I'm going to rewrite it, just a sub n. So then we're just left with n over 5 to the n. Okay. So right here, this looks a little sloppy. So one little trick, when we're dividing by this a sub n, we can multiply by the reciprocal. So what that pretty much means is this first part will stay the same, n plus 1 over 5 to the n plus 1, and then we're just going to multiply by 5 to the n divided by n. Okay, so does that make sense? Okay, so from here now we have to think about what can cancel, what do we have going on that's left. So taking a look here, there's nothing with this n plus 1 and this n that can cancel. However, looking at this 5 to the n plus 1 and 5 to the n, we'll have 5 to the n cancel, and we'll just be left with 5 to the 1. So rewriting this, we're going to have n plus 1 over 5n. Okay. So now what we can do is I'm just going to rewrite it down here again. Limit as n approaches infinity of the absolute value. Don't forget your absolute values like I did. Absolute value of n plus 1 over 5n. Okay. Now we're simply just going to take this limit because we're only in terms of n at this point in time. So as we plug in, let's take a look at this. Sorry. Let's take a look at what we got going on here. We have n to the same power on top and bottom. So we're just going to look at our coefficients. And we're going to say the limit of this is going to be 1/5. Because we have a 1 in front of our n on top and a 5 in front of our n on the bottom. So this following limit would be 1/5 for the given problem. Now we need to see whether this series is going to be convergent or divergent. So if the series is convergent, we have this limit has to be less than or equal to 1. Sorry, just less than, not even equal to, just less than 1. In this case, 1/5 is less than 1. Therefore, the series is convergent. So that's kind of a little warm up for the next question I have. Next question is a little bit more in depth. Kind of one I like to go over just because factorials seem to trip up students quite a bit. So we're going to take a look at number 6 from the same homework. That's the wrong homework. Yes, so number 6 from the same homework. And again, this is going to be asking us to use the ratio test to determine whether the series is convergent or divergent. And then from there, it's going to ask us to evaluate the limit if we can, and so forth. So without further ado, our problem statement is going to be n equals 1 to infinity of n factorial divided by 102 to the n. That looks kind of nasty. So from here, what we're going to do is we're going to identify a sub n, which again, a sub n is just equal to n factorial divided by 102 to the n, which is equal to 102 to the negative n times n factorial. Whatever one you prefer to do, we can do both. And now we're going to take our limit using that same formula again. So we have limit as n approaches infinity of a sub n plus 1 over a sub n. And I'm switching to a pen. Okay. So this is going to equal, yes, thank you, limit as n approaches infinity of the absolute value of a sub n plus 1. So we're going to have n plus 1 factorial divided by 102 to the n plus 1. That's all going to be times, again, our reciprocal, 102 to the n divided by n factorial. Okay, so now let's take a look and kind of think about what we can do. Right away, we see that we have 102 to the n and 102 to the n plus 1. So those will cancel. I'm going to write it here for right now. So we're going to have something divided by 102 to the 1. So just 102. So now we need to think about this n plus 1 factorial and this n factorial. And right off the bat, there doesn't look like much we can do. However, when we have a factorial, what we really have, so if we think about n factorial, that's going to equal n times n minus 1 times n minus 2 times n minus 3, and so forth. And now we can kind of translate that to what we have above. So we have this n plus 1 factorial and this n factorial. This n plus 1 factorial is really equal to n plus 1 times n plus 1 minus 1, which those will cancel. We're just left with n times n minus 1 times n minus 2, and you see the pattern. So we can rewrite this n plus 1 factorial as n plus 1 times n factorial. And if we do that, all we're going to have then is, I'm going to rewrite it up here just above, n plus 1 times n factorial. These n factorials will cancel, and all we're left with then is n plus 1. So we're going to have limit as n approaches infinity of the absolute value of n plus 1 over 102. And if we go ahead and evaluate that limit, we can see that that is going to equal infinity, which means the series diverges. And that is how you would attack that question. So that was kind of an overview of the concepts, topics I had for you. At this point in time, I'd like to open it up to specific questions any of you may have on the homework or anything else. If no one has questions, you're free to go. But yeah, start asking questions if you have them, I suppose. I guess if you don't have questions, feel free to go. If you do have questions, you want to see another example, just tell me and point me to a homework question I can do or whatever else.